Hey guys, so in this video I just wanted to go over some of the distance formula things that you may want to review again right before you take your test or your assessment tomorrow. So first things first, we all want to make sure that we know what the distance formula is. So the distance formula is going to be our D equals the square root of x2 minus x1 squared plus our y2 minus our y1 squared. So in this, what we want to pay attention to is that we're taking the difference of our x values and the difference of our y values. So when we're taking the difference, no, it does not matter the order as long as our first x or our second x value matches with our second y value. Vice versa, our first x value has to match up with our first y value. So whichever one you put first, the y value has to follow that x value. So looking at an example, so the first thing we're going to do is do number 1, where we have m, which is -2, 1, and n, where we have -5, 4. And we want to come in here and identify what is our x values, what is our y values, which one's going to be first and which one's going to be second, just so we can easily plug in our values. So I'm going to call m as my 1s, so x1, y1. And my n is going to be my 2s, so x2, y2. So we started with the formula, the square root of x2 minus x1 squared plus y2 minus y1 squared. Well, now we're substituting in those values. Hold up, let me change that color for you. So we still have equals to the square root, we still have 2 parentheses, and we still have the parentheses squared, and we still have the addition in the middle. But the values are going to change. So our x2 was -5, so we'll have -5. We still have subtraction in the middle. And then we have our x1, which is -2. And then the second parentheses, we're looking at our y's. So we have 4. Still have our subtraction in the middle. And then our y1, which is 1. So once we have our values that was given from our points plugged into our formula for our distance, then we're simplifying. So here we simply have a -5 subtract -2. Well, that equals the same thing as -5 plus 2, because double negatives equals a positive. And this is going to give us -3. The other one we have 4 minus 1, which simply gives me 3. So simplifying the formula after plugging in values, we have -3 squared plus 3 squared. Now looking at this, we have to simplify the squares. So the first part, we have -3 squared. What this is telling me is that I have -3 times -3. Well, a negative times a negative gives me a positive. So if you need to put a little positive there to remind you what's going on. And then I have 3 times 3. So 3 times 3 gives me 9. If you're putting it in the calculator, you have to put those parentheses around it. If you don't put your parentheses around it, what you're telling the calculator is that you have -3 squared, and the only thing you want squared is the 3, not the negative. And that is not what you want to do. Do not just put -3 squared. Have to put the parentheses around it. So also go ahead while we're over here to the right, we have 3 squared as well, which is 3 times 3, which gives me +9 as well. So simplifying our equation, we have 9 plus 9, and then we have the square root of 18. Now this comes out to be an ugly decimal. I'm okay if you just leave it as the square root of 18. Now if we wanted to look at it on the graph, we could. For this one, it's not telling us that we have to graph it, so we don't have to. If you want to, you can. Now we're going to go on to number 2, and I'm going to use a different color, and we're going to come all the way over here. So for number 2, we're given V is 3, -2. And our T is going to be 1, -5. So we're going to identify which one's which. So our T is going to be our 2's, so x2, y2. For our V, we're going to have x1, y1. Our formula again is that D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. And we're substituting in our values, so we still have D equals the square root. We still have 2 parentheses. We still have the parentheses squared, and we still have addition in between. Now we're going to come in and substitute some values in. So our x1 and our y1, our x1 comes here. Our y1 goes back here. We're also going to have our negative still there, or our subtraction still there. So don't forget your subtraction in between your x2, x1, or your y2, y1. So here, I think it was this one, our x2 is 1, so we're going to have 1 there. And our y2 is -5. I'm sorry, it keeps on moving on me. It's -5. So now we're simplifying. So what we want to do is come in here and figure out what our parentheses are going to be. So we still have equals, square root. Well, 1 minus 3 is going to give me -2 squared. The addition is always, always, always still in between there. Then we have -5 subtract -2. Well, -5 subtract -2. That is the same thing as saying -5 plus 2, which we've already talked about is -3. So in our second parentheses, we're going to have -3 squared. Once we get here, we're going to simplify our squares. So we're going to have -2 squared, which is the same thing as -2 times negative 2. Negative times a negative is a positive, and 2 times 2 is 4. So our first parentheses is going to end up being 4. And then we've already talked about negative 3 being squared, but just in case you missed it, or in case you still don't get it, it's saying negative 3 times negative 3. So a negative times a negative gives me a positive, and 3 times 3 gives me 9. So my second parentheses creates a 9. Now under the square root, I have 4 plus 9, which is 13. Again, I'm perfectly okay with you leaving it just like this. So before I go on, if you need to, pause the video and copy down any of the notes that you have missed. Now, in the second one, we did not go over it, and you were not responsible for doing example 3, but I'm going to go over it instead of giving you the answers again for example 2. Because remember, the ones that you're responsible for are example 2, number 1 on the back, 3, 4, 5, 8, and 9. So for example 3, it's just like example 2, except for this time it's only 3 points. So plot the points and connect the points. So I'm going to go on the graph. My first one is negative 3, 0. So start at my origin, go over to the left 3, and there's a 0 for my y value, so there's my A. So I'm going to put my color as A out there. Then my B, I'm just going to choose a random color. My B has a 0 as an x value, so I'm going to go nowhere left to right, but I'm going to go up 4 because my y is positive 4. So my B is going to be 4, or my B is going to be blue. And then my C, let's do it green. My 3 tells me from the origin I'm going to go over to the right 3. And my 0 tells me I'm not going to go anywhere up or down from our y value. So this is going to be C. And let me draw. So I'm going to do a very faded color to connect these. So we can talk about the distance in between these. This gives us an example of one that is exactly right to left or up and down to each other. So in between A to C, we have exactly one length in between dot A and the next dot. So 1 length, 2 links, 3 links, 4 links, 5 links, 6 links. So they're going to be exactly at 6 units to the right to get to C. Now the reason why we can't just count all of them is because when it goes diagonal, it cuts the box unevenly. We can't guess what decimal of that box it is. So like this one may be 0.5 or 0.6 or somewhere in between. But then the other part may be 0.2 or 0.25, and we can't know. So we have to use the distance formula for A to B and B to C, just because it's diagonal from each other. If it is straight across like A to C, you can just count it. So we can come up here and go ahead and answer A to C is 6. Now we've got to figure out A to B. Now on your assessment, the coordinates are already going to be given, So it's not going to be like an example where you're just given this graph and you have to find the points and also plug it into the formula. They're already going to be given just like they were up there. So I've got A to B that I've got to figure out. So I'm going to come over here and get my color out. And my A was I've got A to B. And I'm going to put this little line over it showing that it's that line from A to B. So my A is -3, 0. My B is 0, 4. So I'm going to come in here, identify that my x1 is -3, my y1 is 0, my x2 is 0, my y2 is 4. So I'm going to substitute in, again, distance formula, square root of x2 minus x1 squared plus y2 minus y1 squared. I'm going to substitute it in. So I still have the square root. I still have 2 parentheses. Both parentheses are still squared, and I still have addition in the middle. I also still have subtraction in between my 2 different order pairs. So for x2, I have 0. For x1, I have -3. For y2, I have 4. For y1, I have 0. So here I'm simplifying the substituted values. So for the first parentheses, I have 0 minus -3. Subtraction and a negative cancel each other out to become a positive. So we have 0 plus 3, which is simply 3, squared, plus, now I have 4 minus 0, which is 4, squared. Now these squares are telling me to multiply 3 twice and 4 twice. So 3 times 3 is 9. And then 4 squared is 16. So here we're going to get 25. And that is all we need to put. So we're asked for AB, all we have to put is the square root of 25. So that's going to be our first one. Now we've got to figure out our B to our C. Again, our B to our C, which is right here, was diagonal from each other, so we can't just count the boxes. So let's do our B was 0, 4, and our C trying to keep it color coded for the people that do have OCD. And then for C, we've got 3, 0. So once we have these, then we have to identify which ones are x1, which ones are y1, all of that good stuff. So x1, y1, x2, y2. So I'm going to have D equals the square root, again, x2 minus x1 squared plus y2 minus y1 squared. Still have the square root. still have two parentheses. Both of them are still squared, and there's always addition. There's also always, subtraction in between. So I'm substituting in my B and my C. So my x2 is going to be 3. My x1 is going to be 0. My y2 is going to be 0. And my y1 is going to be 4. So I substitute these in. I'm going to simplify. So I have 3 minus 0, which is simply 3. Then I have 0 minus 4, so that's going to make that 4 negative 4 squared. We should be at the point where we've got 3 squared under our belt, so we've got 9 plus this negative 4 squared is telling me negative 4 times negative 4. Negative times a negative is a positive, and then we simply have 4 times 4, which is 16. So 16. Again, we have the square root of 25. So here we can put the square root of 25. Now it's asking us to find the perimeter. So this one we're finding in our calculator. I do not expect you to do this by hand. You're going to have the square root of 25 plus the square root of 25 plus 6. And that is going to give you your answer. So I'm going to zoom out. So if you want to pause the video, you can, and copy down any of these notes. Now, for this one, this is one of the ones that you did not have to do on the back side, but it zones in on a simple thing that you can do if given points that are immediately right to left or up and down from each other. And I'm sorry for my dog barking. So for each point, they're immediately or exactly right to left or up or down. So when we have points like this, it is not cutting through the box. It is just moving down 1, 2, 3, 4 units. So the distance from these 2 points is going to be 4. The same thing with the next 2. It is exactly 1 unit over 1, 2, 3, 4, 5, 6. So for these, we are not having to cut the boxes weird, and due to the fact of us not counting the boxes or cutting the boxes weird or differently, we're not having to use the distance formula. We can, and we can use it to make sure we're counting correctly, but we do not have to. So 1, 2, 3, 4, and 1, 2, 3, 4, 5, 6. So for this question specifically, you were asked for the perimeter and the area. So for the perimeter, we have to do 6 plus 6 plus 4 plus 4, which gives us 12 plus 8, which gives us 20. And that gives us our perimeter. Now our area is length times width. So that is going to be our 6 times our 4, which gives us 24. So again, pause the video, look to see if you have any questions. If you have any questions, remember you can email me. I'm always glued to my phone, so I'll be able to answer any questions if you email me. Now this one you may have to rotate your phone a little bit, but this one you're also finding the perimeter. I didn't worry too much about you guys finding the area of any triangles just because of time crunch. So we're going to come in here and we're going to identify our vertices or our points at the end of our lines or our intersections of our lines. So here's our green and here's a yellow. So before I start, I want to go ahead and do one that I don't have to use the distance formula for. So in between the green and the yellow, and I'll even name it Y and G, we don't have to use the distance formula because you're going exactly 1, 2, 3, 4 units. So the distance is going to be 4. Now the other ones, you can see how it's cutting the boxes unevenly. So we don't know exactly how many boxes are in between the green or the G to the B, or the green to the blue, or the B to the Y, or the blue to the yellow. So we have to come in here and figure out what the ordered pairs are. So for the G, starting at our origin, we have to go over to the right 1. So our X value is going to be 1. Our Y value is going to be how many we have to go down. So -2. Our B is going to be X value of 3. Y value of +4. Our Y is going to have an X value of 5. And then a Y value of -2. So then we're going to use these to find our distance of G to B and B to Y. So we can use our formula. Distance equals the square root x2 minus x1 squared plus y2 minus y1 squared. So our 2 points we're looking at first is our B, which is 3, 4, and our green, which is G1, -2. So substituting these in, we've got x1, y1, x2, y2. So we've got the square root, still 2 parentheses, still both parentheses squared, and we still have addition in between. We still also have subtraction in our parentheses. So substituting in our x2, we have 1. Substituting our x1, we have 3. Substituting in our y2, we have -2. And substituting our y1, we have 4. Simplifying this out, we have the square root still. We have 1 minus 3, which is -2 squared, plus, and then we have -2 minus 4, which is -6 squared. Simplifying the squares, we have -2 squared, which is 4, and then -6 squared is +36. Simplifying this, we have 4 plus 36, which is 40. So our answer is the square root of 40. And that is from B to G. So if you want to write out the square root of 40. Then we want to figure out the distance in between b and y. So still have the distance formula. If you need to write it down in between each time, that's fine with me. Again, remember, as much as you can give me is on the assessment, the better. So my b is 34. My y is 5, -2. So I'm going to come in here and identify what my x1, y1 is, my x2 and y2 are. I'm going to substitute them in. Still have 2 parentheses. Both of them are squared. I still have addition in between, and I still have subtraction in between. So my x2 is 5. My x1 is 3. My y2 is -2. My y1 is 4. Going to simplify my substitute values in. So 4 minus 3 is 2 squared, plus -2 minus 4 is -6 squared, equals 2 squared is always 4. -6 squared, I didn't do it earlier, but if you need me to do it, this is telling me -6 times -6. Negative times a negative is a positive, and 6 times 6 is 36. So we have 36. And then I'm running out of space, but 4 plus 36 is again 40. So we have the square root of 40 in between b and y. So again, the square root of 40. So for our perimeter, we're having to, I'm just going to mark this out. So if we were asked for a perimeter, we're going to do the square root of 40 plus the square root of 40 plus 4. And that is exactly how you would put it in the calculator to get your answer. So take time, pause the video, and copy down any of those notes you need. Now for number 2. Number 2 is a part of the worksheet you got today that we started on. And we're given points of a triangle. What is the approximate perimeter of the triangle? So how many sides are in a triangle? 3. If we identify the first point as being A, the second point being B, and the third point being C, is that all the points we need? 3 points to make a triangle? Yes. Now, I want to find the distance in between A and B. I also want to find the distance in between B and C. That only gives me 2 lines. What is going to create that third line of the triangle? It's going to have to be connecting C to A. So let's say if it was, making sure I was able to write over here. If A was over here, then B was over here. So we'd have this line, and then C was over here. Well, B to C would only connect these 2 dots. we would still need this line right here on the left to connect and create a full triangle. So for AB, we have 2, 4, and 3, -1. We're going to identify what is our x1, y1, all of that good stuff. So x1, y1, x2, y2. We're going to have our distance formula. So d equals the square root x2 minus x1 squared plus y2 minus y1 squared. I'm going to substitute some values in. So instead of x2, I'm putting 3. Still have subtraction. And I have 2 as my x1 squared plus, instead of y2, I have -1. Subtract. And my y1 is 4 squared. So I'm coming in here and simplifying my substituted values in. So my first parentheses is 3 minus 2, which is 1. Still squared, still addition. And my second parentheses is going to simplify -1 minus 4, which is -5 squared. Because we haven't done it, 1 squared gives me 1 times 1, which is simply 1. Then we have -5 squared, which is -5 times -5. Well, negative times a negative is a positive. We have 5 times 5, which is 25. So we have 1 plus 25. So we have square root of 26 as our answer. So that is for AB. So that is one side. Now for our BC. Our BC is, I'm going to actually do this. So BC, I've got 3, -1. I've got -2, -2. So I want to come in here, identify what my x1, y1, all that good stuff. So x2, y2. I'm going to use that to substitute in to my formula. So we're going to have the square root, still 2 parentheses, still both squared, and still addition in between, and subtraction as well. So instead of x2, I'm going to put -2. My bad for doing the wrong color. -2. Instead of x1, I'm putting 3. Instead of y2, I'm putting -2. And instead of y1, I'm putting -1. So simplifying up my substituted values in, my first parentheses simplifies -2 minus 3, which is -5 squared. In my second parentheses, I have -2 minus -1. So -2 minus -1. Subtraction and negative beside each other cancels out into addition, or keep change. So -2 plus 1 is -1. So we get -1 in our second parentheses, squared. Then we need to deal with our squares. So -5 squared, we've already looked at, is 25. plus, now our negative 1 squared is the same as negative 1 times negative 1. So negative times a negative is a positive, and 1 times 1 is 1. So 1. So the square root of 26 is our BC. And then we have a CA. So our C is going to be the same, and our A is. So C is going to be negative 2, negative 2. And our A is going to be 2, 4. So we need to come in here, identify what is what. So x1, y1, x2, y2. Gonna use the distance formula again, since it's not on the screen. D equals the square root x2 minus x1 squared plus y2 minus y1 squared. Gonna substitute in. Still have two parentheses. Both are squared. Both have addition. Both have subtraction. So our first one is x2. So that's 2. Our x1 is negative 2. Our y2 is 4. Our y1 is negative 2. So we're going to simplify. In our first parentheses, we simplify negative to minus negative 2, or just 2 plus 2 is 4, squared plus 4 minus negative 2, or just 4 plus 2 is 6, squared, equals 4 squared gives me 16, plus 6 squared gives me 36. And then under the square root, we have 16 plus 36, which is 50, the square root of 52. So all of that work to say, to ask, what is the approximate perimeter of the triangle? So we're going to add the square root of 26 to the square root of 26 to the square root of 52. And you should get approximately 17 units. So pause the video if you need to and look over these notes. Now in the last one, we touched on it but did not go over it. But in this one, we're given our points. We came up with a few letters today in different classes. So in this example, I'm just going to put A, B, and C. So just pay attention to which one that you're looking at. So we're going to find the perimeter. So can we count any of these distances? No, because all of them cut through the squares on the coordinate plane unevenly. They don't go from this point to this point, or this point to this point. They go through a box. So we cannot count that correctly. So we have to use the distance formula. So for the first one, we've got the square root of, we're going up from negative 2, 2 to 2, 1. So our x2 is 2 minus our x1 is negative 2 squared plus our y2, which is 1, minus our y1, which is 2, squared, we're going to simplify this to get the square root of, instead of 2 minus negative 2, we get 2 plus 2, which is 4 squared, plus 1 minus 2, which is simply negative 1 squared. And then we have 4 squared, which is 16, plus negative 1 squared, which is just 1. So we get the square root of 17. So this is the square root of 17. Then we have the distance in between B and C. Now we're just doing every single step over and over and over again. So make sure, if you need to, every time come in here and identify what our x1, y1 is, our x2, y2 is, every single time. And I'm going to leave you here because I also want to show you this video. So here's a way for you to remember how to memorize the distance formula.
Okay, class, today's lesson is on the distance formula. The distance formula is d is equal to the square root of parentheses x sub 2 minus x sub 1 squared plus parentheses y sub 2 minus y sub 1 squared. So that is the distance formula. Any questions?
Watch me did this formula. First you square 2 parentheses. Take each difference and add them daily. Then you square root this quantitative. Ooh, watch me did this formula. First you square 2 parentheses. Take each difference and add them daily. Then you square root this quantitative. Ooh. Watch me, ooh, watch me, ooh, watch me, ooh, watch me, ooh, x2, x1, ooh, y2, y1, ooh, flip them for fun, ooh, problem is done.
So, if anybody has any additional questions, please remember to email me. My email is, let me do it so you can actually see it. My email is taylormassey@johnson.k12.nc.us.